By now you should have a much better understanding of nutrition. We have covered our ancestral roots and the foods we evolved eating. We have also covered what food is actually made of and the importance of nutrient-dense foods. Now we need to look closer to home. The next few videos are all about personalising the information you have acquired over the first half of the course. Everyone has different nutritional requirements. Some of us want to lose weight, some might want to gain weight, while others might want their diet to support their profession, i.e. you might be a professional sports person. We know that there is a lot of conflicting information out there. The aim of this course, and specifically the second half of the course, is to give you the tools you need to make the right decisions, from working out how much food you actually need, to label reading and surviving the many pitfalls of a supermarket shop. We're going to start our personal nutrition guide with the mechanisms that make us eat in the first place. Appetite.
Simply put, appetite serves as a mechanism to remind us to fuel our bodies. Today, meal timings are generally set around our schedule and there is often no need for a reminder to refuel. But if we look back into our ancestral past and the way we evolved to eat, it makes sense that there would be a constant need for reminders to go out and hunt or forage. Remember again this key relationship between hunting, gathering and consuming and our optimum foraging strategy. So, as I mentioned, we now generally eat based on our schedules, but this creates a problem. We have become habitual eaters. Now, for some this might not be a problem. After all, some people lead very physical lives and there is a genuine need for a steady stream of energy. For others though, this is a serious problem because appetite and the feedback system that governs it can be easily fooled. For example, you've just eaten a very large meal and feel very full. Then, someone brings out a piece of cake or a chocolate dessert and suddenly you've magically found more space for a little more food. This happens because we are hardwired to eat energy-rich foods. As mentioned earlier, foods that are highly concentrated in sugar and fat are more of a rarity in nature, so if we did find them, then we would consume them as if they were going out of fashion. And this makes perfect sense because we didn't have food on tap, so to speak. It was far better to consume quickly and ask questions later. Now, however, we are literally surrounded by high-energy foods and we can trick our own regulatory system with ease. This exploits a serious flaw in a system that worked well when we were hunter-gatherers, but has ultimately led to a rise in obesity among almost all cultures worldwide.
So before we move on, I just want to address the mechanisms that govern hunger. We have two different kinds of hunger. Homeostatic hunger, which is related purely to balancing our energy reserves short term, and hedonic hunger, which makes use of opportunities to gather extra energy. So in the previous example, we had just eaten a large meal. Let's say we ate a large meal this time of tasteless gruel. Your body signals to your brain that you are full with a hormone called leptin. Now, leptin plays a role in satiety and signals that you have stored enough energy in your fat cells and require no more. After roughly 2 hours of digestion, the stomach begins to finally empty out. The last stage of this emptying process is a hormone signal from the stomach that causes it to grumble, which we call hunger pangs. Another hormone that signals hunger in the hypothalamus, the centre of the brain, is called ghrelin. This makes two cues for us to eat. Now, if we rewind back to the 2 hour mark, we might have just had a meal and we find ourselves presented with something sweet, and we've enjoyed this food in the past, so we've just had the gruel and then something sweet comes along. Now, not wanting to miss out on some extra energy, we can easily override our inbuilt stop eating signals and eat some more. Unfortunately, it's a delicate balance between these hormones, and now thanks to overconsumption, we are breaking down this delicate system as we continue to bombard our body with what we call hyperpalatable foods, and we gradually impair the signals we send to the hypothalamus. The satiety hormone leptin is produced by the fat cells in your body. Its main role is to regulate fat storage and how many calories you eat and burn. When you eat, your body fat goes up, leading your leptin levels to go up also. Thus, you eat less and burn more. Conversely, when you don't eat, your body fat goes down, leading to your leptin levels to drop. At this point, you eat more and burn less. The more fat you store, the more leptin you also produce. The more leptin you have in your system, the less effective the brain is at reading the signals. It becomes fatigued, leading to unwanted outcomes. Number 1, eating more. Your brain thinks that you must eat in order to prevent starvation. Also, number 2, reduced energy expenditure. In an effort to conserve energy, your brain decreases your energy levels and makes you burn fewer calories at rest. So as we can see, although we were fairly robust and highly adaptable as a species, we have limits to what we can do with our own inbuilt programming.
When we consume carbohydrates, the sugars and starches, once digested and absorbed, are converted to glucose and are transported through to the bloodstream. Insulin helps cells to take in glucose to be used for energy. If the body has sufficient energy, insulin signals the liver to take up glucose and store it as glycogen. When we consume food with glucose, insulin also inhibits breakdown of body fat into free fatty acids, and the burning of the fats for fuel, or lipolysis, won't resume fully until the glucose is dealt with. This seamless to and fro between glucose burning and fat burning is down to our insulin sensitivity. If high loads of glucose are dumped into the body, then lipolysis is inhibited to an even greater degree, and body fat therefore becomes even harder to burn. Not only this, but vital organs are exposed to higher levels of blood sugar. If there is no room for glycogen in the cells, then it's converted to fat and stored in your fat cells. When insulin levels spike, then crash, you will also have a physiological response that will make you feel tired and hungry. So this usually results in the consumption of more sugars, leading to a cycle, or should we say downward spiral, and over time your body will become more and more insulin resistant. But remember, the role of insulin is to remove potentially dangerous levels of glucose from the blood into the cells. When you become insulin resistant, you have to produce more and more insulin. This can ultimately lead to pre-diabetes and eventually full-blown type 2 diabetes. Type 2 diabetes used to be called adult onset diabetes until more recently, when children started being diagnosed with the condition.